In this video, we're going to be talking about vertical stretch and compression. We are going to be calling this A. So if you look at the top line here, f of x is equal to A sine x. So A is in front of the sine x, and it does a couple of things to our graph. So our first example is g of x is equal to 5 sine x. So if you notice here, there are two graphs. The blue graph is our original sine x. So this is a graph that you learned about earlier. This is a graph that starts at 0, has its peak at 1, heads back to 0, has its trough at -1, and then heads back to 0. Now, if we look at the red graph is our 5 sine of x. The 5 sine of x is the exact same shape, except now instead of having a peak at 1, it has a peak at 5. So all of these values that we have been multiplied by 5. After it hits its peak at 5, it heads back to 0, so it's resting. And then it heads down to its trough at -5, and then back to 0. You're probably wondering what this 5, or what this A of 5 changes. So the first thing that it changes is that everything is multiplied by 5. And when I say everything, I mean all of my y values. Now, this obviously means that my amplitude is now 5. My period is still 360, so nothing changes that way. And my equation of the axes, so equation of axes, is still at y equals 0. So nothing changed that way either. My resting place, or my middle, is still the exact same. Our next example says, how does the value 1/4 in the function g of x equals -1/4 sine x change our sine x? So again, we have our original graph in blue. So I've kind of expanded this graph so it looks like it's taller, but really if you look, it's still just hitting 1, back to 0, down to -1, and back to 0. Now my new graph, the -1/4 sine x, there's a couple of things that we need to talk about here. The first thing is going to be the negative. So the negative means that instead of starting by going up, we're going to start by going down.
Noah.
The 1/4 means that instead of having an amplitude of 1, we will have an amplitude of 1/4. So we're starting at 0, we're heading down to 1/4, back to 0, up to +1/4, and then back down to 0. So just to recap, the negative in my A value means that we have a reflection in the x-axis. The fact that A was 1/4 means that we have this vertical compression. But really, what it's saying is that our amplitude is now just 1/4 instead of 1. My period is still 360 degrees, and my equation of the axes is still y equals 0. All right, and in our last example, how do the values -2 and -3 in the function g of x equals -2 sine x minus 3 change our original function sine of x? So the first thing that we notice is that we do have this a value here. The next thing that we're going to be talking about is the fact that the -3 is our c value, which we know is a shift up or down. So when I'm taking a look at this again, I drew my original graph in blue, so start at 0, head to 1, back to 0, down to -1, back to 0. Now, the next graph that I have drawn here is the red graph. The red graph is taking into account that we have this -2 for our A. This means, the negative means a reflection, so instead of heading up first, I'll be heading down first. It also means that my amplitude is 2 instead of the original 1. So starting at 0, I'm going to head down to -2, back to 0, up to +2, and back to 0. The final graph that I have drawn here is the purple graph. This is taking into account this C. So this C is a -3. This means that my red graph, or the -2 sine x graph, is being shifted down 3 units. So there's a couple of things that you're going to notice. The first thing is that our equation that used to be at y equals 0 is now at y equals -3. This indicates my new starting point. Now there are a couple ways that you could draw this graph. You could start at your new starting point of -3 and go down 2, back to your middle grounds, up 2, back to your middle grounds. Or you could take each and every point, not just that point, and transform it down 3 units. So this one that was at 0, 0 is down 3 units. This one that was at 90, -2, down 3 units. All of these key points could be brought down 3 units to get to my new graph. And finally, just to tidy things up, we're just going to talk about what's going on with this new graph that I have here. So the first thing is that there is this reflection in the x-axis. The next thing is that we have an amplitude of 2. And we still have a period of 360 degrees. My new equation of the axes, so this has changed because of this C, this shift down, and my new equation is y equals -3. We're going to be talking about our last transformation, our K, or our horizontal stretch or compression. Here I have two graphs. I have the sine theta function and the cos theta function. There's a lot more points on here than I normally draw, so typically I only draw these main features in. So our points that hit our axes, our peaks, and our troughs. These are the 4 points that I'm going to be using when I am calculating my new image points. So moving forward, how does the graph of y equals sine of 3x compare to y equals sine of x? So the first thing that we're going to notice is that this 3 is my k. So this 3 is attached to my x, and it comes after the sine. So if it were to come before the sine, we would know that it would be an a, but since it's after, we know it's our k. So we need to know a couple of things before I can talk to you about what this graph looks like. So the first thing that I'm going to be talking to you about is a formula. So we have this formula that says period is equal to 360 over k. The absolute value of k to be more specific. So just if there's a negative sign, we're just going to ignore that. We're only looking at the number here. And from this formula, I could rearrange it to say that k is equal to 360 over period. But this is not as important if I am given an equation. So this formula would only be important if I was given a graph and I was trying to write my own formula, then I would be using that one. So you're probably wondering, like, what does this mean? Why do I care? I just want to graph this thing. So what you're going to see in this equation, y is equal to sine of 3x, is that my k value is 3. This means that my period, if I plug it into this formula here, period is equal to 360 over k, so 3. So period is equal to 120 degrees. Now in my original sine function, my period is 360 degrees. So that means that everything here needs to be horizontally compressed so that it can do one full rotation in 120 degrees. Now, if I'm going to calculate my new image points, I can do a couple of things. I can divide each of these image points by 3. That will help me compress it because I'm compressing it a third of the way, 1 over k, just like always. But it's not always we don't always have a graph and it's not always that easy. So another way to do it would be to think about this graph in terms of sections. So when I look at my original sine function, I have section 1, which is my middle point to my peak, section 2, which is my peak to my middle point, section 3, my middle point to my trough, and section 4 is my trough to my middle point again. If I'm thinking about a period of 120, I can easily get these key points in by taking my period and dividing by 4. So I know that 120 divided by 4 is 30. So every 30 degrees, I need to be doing, I'm going to use a different color here, maybe I'll use red. I need to be doing one section of my graph. So I need to be drawing up to my peak at 30 degrees. Down at 60, I'll hit my middle. At 90, I'm going to hit my minimum. And then at 120, I'm going to hit my middle again. Now this is super pointy and that should not be like that, but I'm attempting to draw on an iPad that's not working really well. So those are your two options. So you can divide each of these by 3, or you can just think about this graph in terms of 4 sections. Now the same thing goes for cos. So if I had y is equal to cos of 3x, my k is 3, that means my period is 120, and I can just go ahead and do the same thing. So every 30 degrees, I'm going to be getting a new section of my graph. So hit the middle, down and hit the bottom, hit the middle, up and hit the top. And that's really high. Oh, that whole thing deleted. So the period and the k are found using this formula. Super quick, I have a couple minutes here. I'm just going to go through one quick example. So when I look at this equation right away, I know that I can't start labeling my a, k, c, and d because I need to factor this guy out. So 2 times x plus 60 minus 2, this is a bracket there, it just doesn't look right. Now I can talk about my values. So I've got a value of a here. So it's a vertical stretch by a factor of 3. I have a value of k here. Now this means that I have my period is equal to 360 over 2, so 180 degrees. And I have a d value, so my d value is negative 60. So that's a shift left 60, and then I have my c value here, which is negative 2 or down 2. Now if I want to go ahead and I want to draw this, it's going to be really rough. I should have inserted a grid here, but I need to get this in before that 15-minute mark. The 180 is going to be the most important thing that I have here. So if I do 180 divided by 4, I get 45 degrees. So this means that every 45 degrees, I'm going to be going to a next important or key feature of my graph. My amplitude is 3 and my shift down is 2, or my equation of the axes is negative 2. So I'm going to be starting at negative 2 and I'm going to be having an amplitude. I have to move all of this up. An amplitude of 3. So that means that from that negative 2, I'm going to be going up 3 to a maximum of 1, and I'm going to be going down 3 to a minimum of negative 5. Now if I start graphing this, I'm going to be starting at my middle point because I have sine, and every 45 degrees I'm going to be doing my next thing. So up to my max, down to my middle, down to my min, and back to my middle. Sorry, this looks really wonky. At this point in time, I'm going to be using my shift left of 60 degrees. So every one of these key points moves left 60 degrees, and I'm able to get my new graph.